Kia ora Year 9. In this video, I'm going to go through the JAF practice for stats. So I'm going to do videos that are about 10 minutes long, so I'm not sure exactly how many questions I'm going to get through, but this is part 1, so it's mainly going to be the unistructural stuff. Let's start with reviewing different types of data. So the first question here gets you to think about, again, whether variables are qualitative or quantitative, and if they're quantitative, are they discrete or continuous? So let's go back to the picture that we saw in class. When I've got a variable, which is just a thing, right, I ask the question, is it a word answer or is it a number answer? So how long is your foot? The answer is, I don't know, 30 centimeters. It's a number answer. And we call that quantitative. If I ask you what colour are your eyes and you say they're hazel, that's a word answer, and we call that qualitative. Now, we can go on and do some more stuff with putting qualitative data into order, but we don't worry about that in Year 9. So we're really focused on that distinction between qualitative and quantitative. If it's quantitative, we split it into two groups. It's either continuous or it's discrete. Right, so this is all just revision from what we did in class. Discrete means that it's whole numbers, so counting numbers. For example, how many siblings have you got, right? The answer could be 0 or it could be 3, but it can't really be 3.5. So if there are gaps between the answers, then we call it discrete, right? So for example, 0, 1, 2, or 3, and so on. Continuous is where we are measuring something and we can always make our answer more accurate. So if you think about height, for example, and you say that someone is 1.5 meters, well, if you took them into a physics lab at school and you got a more accurate set of measuring stuff, then you could figure out that actually that 1.5 meters might be 1.51 meters. That's to the nearest centimetre. But if you got even more accurate, you could say that no, actually it was 1.50000092 metres, and so on. So there's no limit in theory to how accurately we can measure it. And when that's the case, we've got continuous data. So in this first question, we just have to decide if each of these things is qualitative or quantitative, and then if it's continuous or discrete. So the length of your foot, well, the answer to that is a word, not a word, it's a number answer, so it's quantitative. So I'm going to just do this in the video by underlining which side it is. So it's quantitative and it's continuous because we're measuring it. So it's continuous. Shoe size is an interesting one. The answer is a number, so it's definitely quantitative. But if you think about the answer to that, you might say that your shoe size is 6 or 7, but you might say that it's 6.5. Now, does that suddenly mean that shoe size is continuous? No, it doesn't, because it's not that if I went into a shop and measured it better, they'd say, oh, actually, your shoe size is 6 1/8, right? That doesn't exist. Or 6 1/32. So this one is definitely quantitative and discrete. The distance between cities is also quantitative, and it's measurement. We're measuring kilometres, so it's continuous. The make of your car, Toyota or Mercedes, if you're very lucky, is qualitative. So then we don't worry about this column over here. Your age in years is quantitative because the answer is a number, right? I am 15 years old. And when you're asking for it in years, then we think of that as what we call discrete data, right? The answer is a counting number. But if instead I focus on age and measure it in seconds, then we'd say that it's quantitative, but now we're thinking of it as continuous. So this is kind of an interesting one, and anything to do with time, you can get into some funny distinctions about whether it's continuous or discrete, but that's really how we think about it at this stage. Okay, jelly bean colour is going to be qualitative because the answer is a word. The mass of a newborn baby is quantitative and it's continuous, right? Because I could get more accurate if I had even better scales. The seating capacity of a car, how many people can sit in a car, is quantitative because the answer is a number and it's discrete. So there you go. So that's quite a long first question, but hopefully some good revision. It is really useful to be able to think about types of data because it affects what we can do with those statistics. And you'll see that over the next 5 years as you move through stats at school. Okay, I'm up to 5 minutes and I've done question 1. This is going to take a wee while. Here's question 2. Right, give 3 additional forms of discrete and continuous quantitative data. So you can think of anything here. Here are my 3 for discrete. I thought of the number of earthquakes in New Zealand in 2018. That's the first one I thought of. And then I thought of the number of days on which it rained in Wellington in May. Okay, so the answer to this is a number, but it's a counting number, right? And then the last one I thought of was the number of sticky buns sold by a deli. So there you go. They're all discrete. Now, what did I think of for continuous? Well, they're slightly more boring. The height of year 9s at Dub C would be one obvious continuous one. The length of a caterpillar and the weight of a giraffe. So in all 3 of those cases, the thing I want you to see is that my answer is a measurement and I could make it infinitely more accurate, right? So that's the big idea here with types of data. Okay, now we're into some number stuff, so this is going to go a little bit faster. Let's have a look at question 3. Right, find the range of the data given below. So the range is the maximum minus the minimum. The maximum is the biggest number in there, so let's have a look through. And the minimum is the smallest. Now, if you're just finding the range, you don't need to bother to put them in order. You can just look at it when it's only a few numbers, as it is here. So here's the biggest one, it's 30. Here's the smallest one, it's 16. So the range is 30, take away 16, which is 14. Question 4. Right, we've got information about the number of chocolate bars consumed per month per person by a bunch of office workers. Find the mean and the range of the number of chocolate bars. So let's do the range first, because that's the easiest. What's the biggest number? Well, someone ate 28 chocolate bars a month. That's nearly 1 a day. That's a lot of chocolate. And then this one, the smallest, is 10, which is still quite a lot of chocolate. So what is my range? Well, my range is 28 minus 10, which is 18. Now, how do I find the mean? Well, to find the mean, I add up all of these numbers, and then I divide by how many numbers we've got, how many workers we've got. So let's first count up how many I've got. 1, 2, 3, 4, 5, 6, 7, 8. Right, so 8 people. And let's add up those numbers. So it's going to be 10 plus 18 plus 15. Let's see, what do we get? So we add all of these, and that gives me 156 divided by 8. Or you can write it as 156 over 8. Either of those is fine, giving me a mean of 19.5. Now, don't change that into 20, just leave it how it is. It's fine to have a decimal for an answer there. Okay, so 19.5 for the mean number of chocolate bars. Here's the next one. Now, this puts in 2 new things that we've looked at in class, the median and the mode. So the mode is really easy. The mode is just the most popular number. But to do problems, as soon as I'm trying to find the median, I really, really want to put these numbers in order. Because if I do it like this, I'm going to muck it up totally. So let's chuck the numbers in order. Here's what we get. We get 10, 12, 16, 16, 19, 23, 26, 27, 28, and 29. Now I'm just going to check that I've got them all. So there's 10, 12, 16, 16, 19, 23, 26, 27, 28, and 29. So how many numbers have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could write that as n equals 10. N means the number of things in my sample. And the median is going to be halfway through. So we can do this in a few different ways. I like to think of 2 blocks of 5. So 5 numbers here and 5 numbers here. And the median will be halfway in between those 2 numbers. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5 here. So the median will be halfway between 19 and 23. So we can do this on our calculator, or we can do it in our heads and say, well, halfway between 19 and 23 is just 21. The other way that you can do the median, if you don't like the block way, is the way that you've done in class, which is this. We can go crisscross at each end. So cross off those 2, then cross off those 2. Cross off those 2, and cross off those 2. And now we're left with our middle 2 numbers, and we find half. Either method is fine. It's the idea that we're looking for the middle number for the median. Now, what's the range? Well, the range will be 29, take away 10, which is 19. The mode is the most popular number in here. Let me just get rid of the writing on the numbers so we can see the numbers again. So the most popular number in there is 16. Now, the mode is the first measure of the centre that you learn when you're really little, but it's also usually the most useless. We're going to see an example coming up soon where it does make sense, but usually we're more interested in the median or the mean, right? And we're going to see why soon, but not while we're just building our unistructural skills. Now, the last thing we're going to do is to find the mean, and I'll just give myself back some space. So to find the mean, I don't have to have the numbers in order, but I do have to add them all up. Now, the range has disappeared. The range was 19. So adding these up gives me what? Well, I've got 29 plus 23 and so on. So I add all of those up. And then I divide by how many numbers we had, and we had 10. So the top line works out to be 206 divided by 10. So my mean is 20.6. So there we go. That's those 4 done. Let's just see if I can squeeze in question 6. No, I don't think I can. So I'm going to do 6 onwards in part 2 of this video. Hopefully that gets you started. Make sure that you're really, really confident with all of these skills and use the EP work that we've set to support you with this topic. Thanks for watching.